be on, true, before the output is true. So in this statement, this is an or, so if this one is true, or this one is true, and this one is true, well, we have to decide which thing is done first, just like you have to decide which thing is done first when you're doing addition versus multiplication. And in this case, ands are done before ors. They have higher precedence. So we have to go through this string and find the first and. Okay, that's the and. So if we kind of put parentheses around these two things here, age greater than or equal to 65. I did start the recording, did I not? Yep. So if we put parentheses around here, that would have to be evaluated first. Is their age greater than 65 and the rating G? Great. Then go. But if this wasn't true, it has to check this side. And we already talked about that short-circuiting stuff where, if this is true, it just skips all the rest because it's an or, right? But without these parentheses here, we wouldn't kind of be able to eyeball it. I like using parentheses just to make things clearer. But as long as you understand the rules of precedence, then you don't necessarily have to. But in this case, they decided the logic was not correct as written. They decided that the parentheses needed to be done here to force that to be done from there to there before it did the and. I don't know what they're checking here. If your age is under than 12 or greater than 65 and the rating of the movie is G, I don't know. I guess they're giving low cost, to get people to go see family-oriented movies. So anyways, I want to show you all something that you'll see if you go on and take for your college courses in programming or logic or something like that. If we treat multiplication, well, I should say, if we treat and as multiplication, and we treat or as addition, and we treat not, well, I can't think of a way to phrase it other than not. But you could use these symbols to represent your logical statements. So, let's say that back in the medieval days, you could be considered guilty if, you had a witness to the crime or you were poor. Right? So you could write this as guilty is equal to witness. Now what's that? An or? Like that. Now that's very cynical, right? But anyways. And so also, let's say that you could be innocent if you did not have a witness or you weren't poor. Like that. So we would rephrase that for a logic class like that. And you can combine combine these expressions as long as you need to. Now, in our language, we don't use plus sign for or. We actually use the word or. When you go on to take other languages, you'll see that used as or. Just kind of tuck it away in your brain for when you take Java or C, C++, whatever, that you're going to see vertical bars as meaning or. And then for and, I always go to that hungry and go to the, go out to eat. Go to the restaurant, out to eat equals hungry, and you have money. So that would be hungry times money. But there are other times you might want to go out to eat. If you're not hungry and you don't have money, you still might want to go out to eat if you have a friend who's buying. If you have a friend who's buying, maybe you don't care whether they're hungry or not. Whether you're hungry or not. Out to eat, is equal to hungry or money, or you have a friend who's buying. So that would be hungry times money times friend. You have three cases here, and if any one of them is true, that's good to go. Now let's give another clause to this. How can we go out to eat if we don't have anywhere nearby to go? So, we're going to go eat if we're hungry, or we have money, or we have a friend, and there's a restaurant nearby. But that's not right, because what did we say? Ands get treated first. So, effectively, that would be done like that. And we don't want it done like that, right? We want all of this to be done separately from the food nearby business. So really, in order to counteract the higher precedence of and, we'd want to do it like that. So, if we're either hungry or we have money, oh, I said that was going to be an and. My mistake. You have hungry and money, or you have a friend who wants to go out to eat. And this was an or, and I said up here that or was addition. I've made some mistakes for which I apologize. We'll step through it again. Okay, so if you're hungry and you have money or a friend and there's food nearby, then you're going to go out to eat. That's cool. Let's figure it out if the rules of precedence are good or if we need to put extra parentheses around it. If here's the and, hungry and money, yeah, that should be evaluated separately from or friend, because even if we're not hungry and we don't have any money, if we have a friend who's going out to eat, then we can go with it. So as long as that's true, then we would check this condition. Is there food nearby? Both of these cases have to be true. We have to have a reason to go out to eat, and we have to have food nearby. So we could rewrite that with our symbols. Hungry and money or friend, except I wanted to use that, and food nearby. Now, just like your rules of distributive properties when you were doing math, and you could take this multiply and you could multiply everything by it, you could do the same thing here. I'm going to shorten these variables to just like two-letter variable names. If you're hungry, or you got money, or you got a friend, or you got food nearby, all right? I'm just shortening it so that as I do the next thing, it kind of makes sense. So I'm going to take this and I'm going to distribute it through everything inside the parentheses. This is multiplication, so I'm going to have to distribute it via multiplication. Who times Fn times money times Fn, no, I'm goofing that up, plus Fr times Fn. I'm kind of thinking that that's not correct, that I've done that wrong, and so I'm just going to blip past that. Okay, so we have that phrase, and if you were going to write it in one of the other languages that don't use ands and ors, but they use those symbols, an and are those symbols, and an or is that symbol, and an and is that symbol. And in our language, it would look like this. We're hungry, and we have money, or we have a friend, and there's food nearby. All right. Just wanted to kind of get that burned into your brain, the idea of using the ands and the ors, and it can actually be a fairly long expression. Do you have to store the result of a logical expression like that in another variable? Right now we're treating it as it's a flag. I know I introduced that term. Right now, eat is a flag. It's a Boolean variable that lets you, store the result of that calculation and then do something on it later. Get in car, whatever we're doing if we're going to go out to eat, right? So, or you could just put all of that right in the if statement. If, and then we just copy all this. Get in car. These two things mean the same thing. From here to here, we're using a flag to store that logical value. And here we're just evaluating it, on the spot when we need it. There's no real argument between doing it one way or the other, as long as it's a fairly easy expression to figure out. And this one is not too difficult to eyeball right here. But if this was a complex expression, you might want to store it in a variable just so that you could print it out. Not so much in the case of a Boolean variable, but if you had a math expression that was very long, storing it in a temporary variable so that you could print the value of that value out before you went on, so you could kind of eyeball it, double check it. That's one reason to store things in a temporary variable before you act upon them. So we could print out eat right here, and it would print out true or false if we did that. You know, and here, it's not going to print out true or false. We could add another print, you know, like this. I'm going to kind of delete what I do here. Else colon print false. All right, you're making me sleepy with the yawns. Okay, so here we go. These do the same thing right here, just a little bit differently. There's always more than one way to do things. I would personally probably rather just print out that variable if I was trying to debug it, rather than tack on 2 print statements and an else clause just to get it to work. All right, I'm going to take it back to where it was before I added the debug print statement. It's okay to add extra print statements in your code. You can always go back and take them out. If you're trying to figure out what's wrong, you're trying to figure out why the result of your equation is wrong, go ahead and add some extra prints to figure out what it's doing wrong. So mixing your and and your ors does make logic more complicated. You can avoid mixing and or decisions by nesting if statements. What does that mean? Well, if you have ands, if you have if A and B, then do something, then you can still do if A, if B, do something. Those do the exact same things. This code is logically equivalent to this. A nested and is the same, nested ifs are the same thing as using an and. Which one looks better to you? Well, yeah, it's kind of up to you which way you'd rather do it. If you need to be doing a different else here and a different else here, then this would not be good enough. You know, if you had like a whole bunch of different conditions. But if you just have something or nothing, then you could word it this way. And so just kind of remember that nested ands can usually, I said it again, nested if statements can be replaced with an and. How about or? If A or B do something. That could be written as this. If A do something, else if B, except in our language it's called elif. Do something. These are equivalent, right? Because if A is true, it's going to do something. If A is false, it's going to come down here and see if B is true. And if that's true, it's going to do something. So if you have sequential ifs like that, if, else, ifs, and they're all doing the same thing, then you can replace their logic with or. Now, I would not do this. This is nothing wrong with doing it like this, but I would shy away from having this code repeated several times, right? Because what if you had A or B or C or D? You don't want to write LFB, LFC, LFD, and then just have it keep doing the repeated code here. You know, anytime you're copying and pasting code, think to yourself, there's probably a better way to do this. So that's the same as that. This is the same as that. And so this is going to give us some possible permutation of that here. You can avoid mixing and or decisions by nesting your if statements. Let's see if we can figure out how to do that with our hungry and getting in the car and all that business. We see an and here. So I'm going to copy this, paste it down here, and then start trying to reword it. So since we have an and here, that could be replaced by nested ifs, like this. Whoopsie. If hungry and it's Monday, no, wait. If hungry and we have money or we have a friend, I should have not abbreviated these things. Then you could have another one. If food nearby, then get in the car. Those are logically equivalent. Is that easier to read? Might be. How about this expression? Could we break this up? I wouldn't want to break it up at the or. Like I showed you here, breaking things up with an or by stacking them with elifs, I don't really dig. So I think I would probably leave it like that. But the book's going to go on and probably show us how we can do that. But not through a chart. All right. Here's something that our language doesn't even support. We would have to pop open C++ or Java to do it. But I'm going to demonstrate it to you anyways, because the book covers it. Maybe there's a question on it in the, MindTap exams. I'm not going to ask you about it in my exams. Not till you start taking C++ or Java, something like that. Oh, and by the way, enrollment coming up. It may already be open. It's a good idea to enroll early in your classes. Why is that? Because if they see strong demand for a class, they'll go ahead and add sections. If they see weak demand for a class, it could get dropped. And I will give extra credit on the final if you prove that if you say that you've enrolled in a business course or a multimedia course or a CIT course. So I'll post about that towards the end of the semester, That way, say, yeah, I've enrolled in C++ or Java or some cyber course or whatever like that, and you get a little bit of extra credit. And I'm not the only prof that does that. A lot of us do that so that, encourage early enrollment. Helps people iron their schedules out. It's kind of a drag when a teacher's class gets canceled because then you probably have to schedule that teacher somewhere else, and then an adjunct may have been teaching that class and that adjunct doesn't get to teach, and so he hates the college, that kind of stuff. So it's good to early enroll. Make sure that you get the classes that you want. All right, so case statements. Case statements, say we had something like this. If the material is ice, its density is equal to 0.98, where the density of water is 1. So ice floats because it has less density than water. So else if the material is water, then the density is 1. If the material is, wood floats, so it's going to be less, than that, but, iron sinks, whatever. I'm going to make up numbers. I'm not going to look up the density of iron. Let's say that it's 8 grams per, cubic meter, whatever. And what's the heaviest materials known? I don't know. Uranium is heavier than iron. Then the density is 16, whatever. Totally making that up. You could rewrite that if you're using a language with a switch statement like this. Switch on the material variable. And if it's ice, then the density equals 0.98. But if it's water, the density, you see where I'm going with this, is 1. If the material is iron, so case iron, then the density is 8. And if the density is uranium, then the density is 16, like that. So that's the difference, or that's what a case and a switch statement does. You can kind of see, it does the exact same thing. If you think this is easier to read, that's cool. If you think this is easier to read, that's cool. There are things you can do with switch statements that you can't do with if statements. There are things you can do with if statements that you can't do with switch statements. So when you take those languages, you'll have to make an informed decision about what you want to use. Case statements are used for mutually exclusive choices when you're using else ifs. Because if it was possible for something to be both ice and iron, like if you took that out, obviously that's stupid. But, if something could both be ice and iron, then this wouldn't work because here we're only going to do one thing. So that's a switch. The case structure. You use when there are several distinct possible values, whether it's ice or water or iron. Each value requires a different subsequent action. If the densities of ice and water and iron were all the same, you wouldn't even be using an if statement or a case statement to try to figure it out. So here's what it could look like with an if statement. Is the years equal to 1? Your tuition is $175. Have you been here 2 years? Your tuition is $150. I don't know what college this is where your tuition drops every time you go past another year. If the year is equal to 3, your tuition is $100. If your year is greater than 3, or else everything else, then your tuition is $60. And here where we see the pseudocode for the same thing. By the way, if you have a bunch of if, else ifs, that's called an if cascade. I don't think this book talks about that, but a cascade being a waterfall kind of thing. You see that, like that. So this is the same thing right here. And you can kind of see it getting more and more indented because they didn't use elifs. And I'm not going to rewrite it, obviously, because this is not editable. But you want to do it with a switch. Switch based on the year. If the year is 1, tuition is $175. If the year is 2, it's $150. If the year is 3, it's $100. If the otherwise, in every other case, the tuition is $60. And so case year. Case 1, tuition that. Case 2, tuition that. Case 3, tuition that. Otherwise, the default, which I didn't show in my notes, is that. This is easier to flowchart than this, in my opinion. This is a lot clearer. Code-wise, I don't think that it's that much clearer. When I was looking at the code, it didn't look like that was remarkably clearer than this, right? But flowchart-wise, it sure was clear. But this is the last time I'm going to talk about switching case. So I'm not going to ask you to flowchart it or whatever. You can just tuck it away in your brain. I'm hoping that a lot of y'all are going to take other programming classes, whether from me or somebody else. I'd love to have you back. I like getting to know students from semester to semester. And once you know how I teach one class, you get the idea, and it's easier to take the next one. You already know the expectations. And that is the end of Chapter 4. What are we going to do as far as homework is concerned? Where we are. This is the first time I've used the book. So what that means is that my homework assignments do not exactly sync up with the chapters. So let's go see what people have done, what we've done in the past. The new D2L is annoying because it used to show you your newest classes first on my screen. Now it shows the oldest classes first, so for me to find it, I have to go all the way down to the end. No biggie, Teacher problems. Big deal. Alrighty. I teach C++ over the semester if you want to take C++. That's the only, that's a class that I would recommend if you want me over the summer. In the fall, I teach a lot of other things. What could we do that had and or? Let's just go look at the textbook itself. don't want just multiple choice questions. I want a programming problem. Well, that would probably do it right there. All right, we'll do it like that. I'll tidy it up. But that's going to be the homework. Like I said, I'll tidy it up. I'll give you this Word doc, and you're just going to go through and write down whether, an expression is true or false. Is the big number greater than the small number? Yeah, that's a true. Is the big number less than the small number? Yeah, that's a true. However, I'm going to go through and replace it so that instead of being big number and small number, because that kind of gives the game away, right, without even having those variable definitions up there, I'm just going to make them X and Y, right, so that you have to look to see the values of the variables. So it's going to be slightly more difficult than it is out of the book, and it also means that you can't Google, at testanswers.com, the exact answers and copy them. That's why I don't do many assignments straight out of the book, because I know how easy it is to go and get answers, online. All right, so just memo to self, fix that up. So what are we going to do today? It's almost time to start talking about lists. And I don't know whether to do the lecture on them first or just to jump into the program and do them first. Oh, it's time for looping, they say. All right, looping. Looping's cool. Let's write some loops. We don't need to read the PowerPoints about loops. Let's just jump right in. So go ahead and crank up idle and make a new file. And so what is a loop? One of the programming structures we've talked about as well as decisions. And we've been flowcharting loops all along. The decision box, the decision diamond with a line coming back to it. So this is going to be a little bit of a review too, but we want to make sure we do a good job of it, of talking about it. So, name and then loops demonstration. Okay, so let's just print out a series of numbers. Simplest loop possible. I want to print out the numbers between 1 and 10. How am I going to do that? Well, I'm going to set a variable. I just used x. And I'm going to say while x is less than or equal to 10, print x. And then update the loop variable, x plus equals 1. Or if you wanted to, x equals x plus 1. I'm going to do that x plus equals 1 because lots of people got that question a little bit wrong in the exam. That reminds me of something else I need to talk about, how you can get points on the exam to make up for questions that more than half the class missed. We'll get to that before the end. At about 12:30 or 1:30, I need to hit that. So there we go. If we run that, we pretty much know what it's going to do. It's going to count from 1 to 10. So today's March 28. Yeah, happy Easter, everybody who celebrates Easter, because I believe it's this weekend. Happy Chocolate Day if you don't, because you can still go and get chocolate, on sale after Easter. So I'm going to run it now. And as expected, it printed 1 to 10. Now I want to show you a variation of the print statement, which I'll probably never use again in here. If you go on and take a scripting class, I'll use it. But what if you didn't want each print on its own line, right? That's kind of annoying, perhaps. Maybe we'd like all the numbers to go, left to right, rather than all up and down. So just copy those 4 statements, and we're going to make a modification to the print statement to get this to work. Print an X, and then make its ending equal to a space, rather than, okay, don't add what I'm about to do here. Don't add this, because I'm going to delete it. But you see that? That's the way the print statement really works. It prints X, and then it prints out a /n, which goes to the new line. That's an escape sequence. That means go to the new line. And if you did several of these, it skips several lines, just like hitting enter. And the typewriter rolls up every time you hit, /n was sent to it. So what we're saying here is I don't want to go to a new line. I just want to print a space after I've printed the number. So I'm going to delete that now. We are replacing the end character from being the new line character, which is the default, to being the space. And so now when I run it, it's going to print them out horizontally. There we go, like that. That's kind of cool. Maybe I'll use that again, but that's slightly, Maybe when I'm demoing it, I'll use it, and then not. The only problem with that is we're going to have to tack on one more print statement, and I'll show you why. If I do this, print done, since we never had a /n up here, what is it going to do? It's going to print all the things and then done right there. Maybe that's what you want, but maybe you just want it to go to the next line. If you want to print a blank line, go to the next line after you've printed out a line of data like that, you can just do that. If you say print nothing, it'll just go to the next line. Okay, so these 2 things do the same thing, really, except that print, just did it all on one vertical line. There is a shortened syntax for this called a for loop, a range-based for loop. The textbook is probably not going to talk about a range-based for loop. They may. It'll certainly talk about for loops. In one language, and don't type this, you do it like this. For x is equal to 1, keep running while, like I said, don't do this unless you're just going to, I could do that. X is less than or equal to 10, and then each time, do that. And I'll explain what this does in a minute. And then print x. I wish Python followed that syntax. C, C++, C#, Java, JavaScript, a lot of languages do. What this means is start your loop, give x a value of 1, and keep running as long as x is less than or equal to 10. And each time you're done with the iteration, add 1 to x. Does the same thing as this, but like in 2 lines rather than 4. Why is that? Because we had to have an initialization step. We had to set our loop control variable to a value. Then we had to have a condition, and the condition as well as less than or equal to 10. And then we had to have the update. And then our action, right? So we have 4 pieces here, but this lets 3 of the pieces be done on one line. So I'm going to modify these a little bit to be more like what Python is going to require us to do. And I'm going to take out the less than, equal to, and just replace it with less than. I'm just going to do that with this same block of code here. Copy that block of code yet again. Come down here and paste it. So this is another example, right? But if I want to make this say less than rather than less than or equal to, I'm going to have to change that number. Because what happens if I just make it less than 10? What is it going to count?
Up to 9.
Yeah, it's going to count to 9. So I'm going to have to change that to 11 to get it to go all the way up to 10. Now, the only reason that I did that, because honestly, I like this a lot better, right? Tells you where you're going to stop. This requires a little bit of a brain flip. I'm going to stop at 11? No, I'm going to stop before 11. Now, the reason I'm showing you that is because when we do the Java for loop, we have to word it like that. Here's what the Java for loop, sign of Python. Here's what the Python for loop looks like. For x in range, starting at 1, going up to as long as it's less than 11, adding 1 to it each time. I'm going to change this up a little bit. Print 4, comma, x. Right? That way it'll just print out something different. We can see that it's doing over the for loop rather than a while. Okay, so we see now, right? Does the same exact thing. It prints 1 to 10. If you're going to use a for loop, you just have to flip your brain around just a little bit to remember that this is 1 past the end, just like this was 1 past the end. There's no way to get a for loop to work in Python where you do that. You got to always go 1 past the end. Now, what's that number? That's how much to increase it by each time. Let's play with that. Let's count something that, let's make something that'll go from 0 to 1,000 by 50s. I don't know why you'd want those numbers, but I'm going to copy these guys right there and paste them. I'm going to push my code up a little bit. And if you came in late, you can still pick up, just starting with these for loops. Alrighty, so I want to start at 0. I want to go up to 1,000, but I can't do it at 1,000, right? Because that would not include 1,000. This is inclusive on this end, and it's exclusive on the other end. If you remember drawing your little number lines, and one symbol meant inclusive and the other symbol meant exclusive, and it's been so long since I did that, I don't remember. Like one was a hollow dot and the other was a circle, whatever. So I'm actually going to have to increase this by that, and I want it to go by 50s. And it did. It counted from 0 to 1,000 by 50s. We'd better add some comments because this is kind of cryptic for the first time you see it. Count from 0 to 1,000 by 50. And this one is count from 1 to 10 by 1s. See if you can write a for loop that does the same exact thing. I'll give you just about a minute to do that. I'll also do walkabout and make sure that nobody's got syntax errors. That's stinking. Rewrite this with a while. What we're going to do is we're going to take that last for loop and write a while loop instead that counts from 0 to 1,000. So let me just add that as a comment. I'm sorry I didn't make that clear. Write a while loop that counts from 0 to 1,000 by 50s. That makes sense? Oh, and I haven't mentioned it, but if you ever have a religious holiday that interferes with your school schedule, I don't know if all professors do it, but like if you have a quiz, an exam on a certain day that, is an important day for your religion and you're not supposed to do things like that, just tell me, and I'll make accommodations. So, who's got this done? Somebody read it aloud to me. Now, don't make up holidays. This is, Flying Spaghetti Monster Day, and so I have to take the 2 months off. Can't do that. All right, so somebody tell me the syntax for writing a while loop that counts from 0 to 50. What should I do? What should the first line be?
X equals 0.
Yep, x is equal to 0. And what's the next line going to be?
While x is lesser than or equal to 1,000.
Yeah. I'm going to go ahead and make it say less than 1,001, just so it will match this exactly. But honestly, if I was coding it myself for my own purposes, I would do it exactly what you said. So while x is less than 1,001,
Print x.
we're going to print x. And then lastly,
X is
Yep, x is plus equals 50, or x equals x plus 50. So that code right there does the exact same thing as that code, except I didn't print a word there. So I'm going to put a word in front of the x to show that we're doing a different kind of loop. Just for visual display, because you know this long series of numbers, kind of boring to look at. All right, so they did the same thing. So that's looping in a nutshell. One more thing about a loop is that you can break out of the loop if you absolutely have to. It's kind of introducing spaghetti coding back into it if you do this. But I'll show you what I mean. Just grab this code right here, the for loop that goes from 0 to 1,000. Paste it, but we're going to add a break statement. Why? I don't know. But if x is equal to 500, break. What is that going to do? Well, it's going to work just like it was doing, but when it finally reaches 500, it's going to exit the for loop early. Yeah. And you can use that like if you hit an air condition, right? You don't want to just keep repeating, you know, your code. If you hit an air condition, you may want to break out of the loop. Who's missing the X? Anybody else getting some crankiness? That is a cool background. So if I run it, the for loop is only going to print up to 500. I'm going to add a print statement to make exactly clear that it broke out of it. So if x is equal to 500, I'm going to print oops, time to break. So I'm just going to add that right there so that as it runs, I can see why it stopped early. Now what I tend to use break statements for is for handling signal values, where you say, you know, enter a number between 1 and 100, or 0 to quit. And then in that loop I can say, oh, if input was equal to 0, then break. Now since the book hasn't been teaching that method, I've been trying to avoid it. I may get back into it, you know, at a certain point in time. So that's a loop. We've covered two kinds of loops. If I want to put some comments in about a loop, there's my 3 quotes, you know, single quotes or double quotes. For a loop, you must A, initialize the loop variable. And then B, you have to have your comparison. And then you do the body of your work. And then D, you update the loop variable. Just like we did with while, right? X is equal to 1. And then we did a comparison. While x is less than or equal to 10, or while x is less than 11. What was the body of our work? We printed it out. And then we updated it. If you don't have this D here, it's going to be an infinite loop. And I almost always make that mistake while demonstrating in front of a class. I'll show you what I mean. You don't have to type this, but you know, here I'm going to deliberately make a mistake, and it's going to be an infinite loop. Say I want to count from 200 to 300. So I say x is equal to 200, while x is less than 301. Print x. All right, that looks great. And when I run it, nothing ever changes x. So x is always going to be less than 301. So I'm going to have to break the code because it's just going to keep doing that forever. No matter how long I wait, nothing ever changes x, so it never breaks the loop. That's an infinite loop. Maybe I'll add that as a comment. A couple more apostrophes, This is an infinite loop because x never gets updated. So the comparison, which I probably should have called condition, never becomes false. What if the condition was bad to begin with? What if it's just flat out not true? X is equal to 1,000 while x is less than 10, print x, I don't know what we're going to print, hello. Okay. I almost made the mistake of not updating the x variable, so x plus plus, that's c, x plus equals 1. And then I'm just going to print a done right there at the bottom. Because otherwise, honestly, it's not going to print anything once it gets to this point. We're never going to see the word hello. So if I run it, what do we see it do? No, come on. It never printed hello. It did our for loop up to 500 and it did its break, but it never got to do hello. Why is that? This condition was never true. We set x equal to 1,000. It's like an if statement, right? If it said if x is less than 10, it wouldn't do any of this stuff. And so since it says while x is less than 10, it's still not going to do anything. Hope that makes sense. If the condition is false to begin with, it doesn't even go into the loop, just like an if statement. I think I'll flowchart the while loop once more, even though I've done it in the past. I'm not going to make you do it. Feel free if you want to. And it's getting to the point where, like I said, you want to get extra credit on your exam. We need to handle that. Alrighty, so I'm going to go to Lucid Chart. No, I'm just going to draw it. Okay, so a lot faster that way, right? Let's go up to a good while loop. Let's do this while loop. So what's the first line of my while loop besides the comment?
Declaration.
Yeah, we could call that a declaration. I'm just going to assume that we've already declared x or something like that. What value did I set it equal to?
0.
Yeah, okay. And then what's next? We have a while, which is a form of decision. Book never shows putting the word while there. I always put the word while there. Feel free to do one or the other. And if it's true, then we go and we do the body of the loop. We output while. Outputs are done in what shape? Tilted rectangles. Why am I calling it y? X. Then we have to update our loop control variable, which is math. So I put it in a process block. X plus equals 50 or x equals x plus 50. Now I have to loop. And the book always shows looping back up there. I always showed looping back up to there in previous semesters. But I'll go with what the book does. And then, it kept going from there. All right, that's a while loop. If it was an if loop, wouldn't loop back up there. Just separate and join back together. And while we're talking about flow charting, I want to remind y'all, I'm sure that I think we covered this, but what statements can you combine in a block and what statements can you not? Declarations, yeah, go nuts. What is a declaration? It's when you give it a starting value, you know. No math should go in a declaration block. Can I write that tall? Okay, you get the idea. Declarations, that. Then, don't put multiple math statements in a single block. Z is equal to 30, you know. I understand the impulse. I put a lot of things there. Why can't I do a lot of things? Oh, you know, 30 times A, you know, and, you know, A2 is equal to Z times, you know, divided by B. Whatever, you know. Don't do that. Don't put multiple calculations. Break them out. You know, so this was A2 is equal to Z, you know, divided by B. Whatever. Break out. So don't put multiple calculations in a single block. And lastly, unless you're sure that you're going to be getting two pieces from your data source in the same input, unless you can justify it, don't do multiple inputs in the same block, please. Now maybe if you're making a call to a database, you're going to get all that answer at one time. But right now we're asking the user for the data. And so each piece is a separate input block. And I feel the same way about print statements. If you're going to print out X, and then you're going to print out Y on a separate line, you got to combine them into separate things. But you know, if we're doing like we sometimes do and put multiple things in our print statements, sure, combine them in an output data block. All right, I'm going to go back to the exam and see if we have things that are ripe for bonus, not bonus, for recovering missed credit. So, uno momento while I go and look that up. What did I do for the other class? We'll zero in on those. What? Did I just not do it for this class at all? Did I do it for C++? Yeah, that was for C++ now. Okay, but we're going to do the same thing. Oh, I forgot. This is the Tuesday, Thursday class, so I need to check the Monday, Wednesday class for that. I get my days mixed up. There it is, message right there. Possible extra credit for exam 1. I'm going to copy this message, you know, and reformat it if we come up with different questions that I want you to do this for. So that class kind of went off the rails on questions 21 or 24. Let's go look. I want to make sure that everybody knows how to check their quizzes. You pull down on the little down arrow, you choose submissions, and then you click the, you know, the blue submission. That way you can look to see, you know. All righty. Statistics by question stats. Which ones look ripe for credit? 20's really low. Okay, 34 is really bad. Was that what we said here? No, y'all did different questions. It's always funny when the classes do a little bit different. So, y'all are going to check questions 34. And if you missed any credit on it, tell me, and you'll get credit for it. And also that one that had the 2 possible answers, the binary question, let's go look to see what number that is. Come on. Come on. Modern computers have more power than supercomputers of the 80s, and yet everything is still slow. All right, where's that binary one? La-di-da, la-di-da. Come on. Where'd it go? Where'd it go? Okay, and question 21. If you missed any credit on question 21, tell me that as well. I think that was the one I said for here. Okay. So it's going to be questions 21 or 34. So, the rules of the game. Look at your exam. If you missed either question or received partial credit, you can get full credit. Just create and upload a document. You don't know how to do that. Type it in Word or whatever. Saying which questions you missed. You'll get full credit for them. If you didn't miss them, just upload a document saying, hey, I didn't miss them, and you'll still get 1 point of credit for your trouble going to do that. That's to convince everybody to go look. Does that sound fair? So, you might get 2 extra points of credit, or however much these were worth. I forget how much these were worth. If they were 2 points each, then that would be 4 points, whatever going up there. So give it a shot. Go and look. Upload a document. Let me make a Dropbox for that. And we'll do a Dropbox for our daily loops and for our homework from today.
I think that might have been the wrong class.
Am I doing this on Monday again? Thank you. No, this was the right class. Thank you for telling me, though, because as you've seen, liable to do that. I'm going to call it a credit refund. Right. Get some extra credit out of it. I'll upload the instructions for it as soon as I tidy them up a bit. And heck, if you've already figured it out, it was questions 21 and 34, you could upload it right before you leave. That's what you want to do. All right, that folder is there. Let's make a folder for the newest daily assignment, which is IJ. All right, there's a folder J now. Go ahead and upload your Python script there. And notes you can always put your notes in there too if you want them all in one place. Let me remind you that there's something up here under Tools called Locker. And if you ever want to upload something from your school computer and be able to get to it later, you can put it in the locker. You don't have unlimited space there, so you're not going to be able to stick your MP3 library there. I know a lot of people use Google Drive and stuff like that, and that's better. All right, and we're going to have a homework folder, so it's going to be homework 7. Questions from book for chapter 4. And we'll make it do a week from today. Alrighty, gang. Let's go ahead and end a couple minutes early. We can hang out and talk about homework. If not, free to go. And I'll see y'all on Tuesday. Yes, sir.
I don't see the folder. Yeah, I can see the. You did it in the wrong class.
Which one did I goof?
You were on L.
Pardon me?
In class.
In class J,
You should be on L.
H-I.
Yeah, you're in the wrong class. 2067.
You told me I was in the wrong class. I am in the wrong class. Dadgummit. See? You're smarter than I am. That was pathetic. Sorry about that, guys. That means that I put the credit refund in the wrong drop box for them. They're probably looking for it. Sorry to waste your time, guys. Told you, I'm dyslexic about dates. Come on, come on, come on. I'll fix it up, make it look pretty later. All right, L is there now. The extra credit revision is also there now. Just remember, you all have different questions, so I better edit the folder. All right, guys, as soon as you get it uploaded. See, I said see you Tuesday. That's not what's going to happen. See you on Monday.